Hello again. All right, now we're going to talk about part 3 of the discussion on the interwebs about programmer-defined methods. And this topic is about something called stubs. Now, if you remember when I first started trying to sell you on the idea of programmer-defined methods, I said it's a really nice way of thinking about the design of your program. Mostly when programmers write code, they tend to think in a top-down design way. And what I mean by that is that you think about the big picture and you don't worry about the details at first. The details are something that you can worry about later. And the reason why you do that is because it's really hard to think about all the details, all the little nuts and bolts and crazy things that you're going to have to do in your code to solve a particular problem. It's just too much to think about at once. So if you think about the big picture and break the big picture up into little pictures and break those little pictures up into littler pictures, it's a much easier way of solving a problem, a big problem. And when you're using programmer-defined methods and you're doing top-down design, stubs can really help you get your code up and running pretty quickly. So to help motivate this, what I'm going to do is we're going to write a program that has the following goal, solves this following goal. We're going to input user age in months or days, and we're going to output the user age in years. And then we're going to repeat this over and over and over again. So the first thing we need to do to get this coded is to think a little bit about the design. And we can do that in a way that is writing the design down on paper first without writing any code. So that's what I'm going to do first. So remember, I'm going to input the user age in months or years, and then we're going to output the user age, or months or days, and then output the user age in years. All right. So one of the things I need to think about here is how am I going to know if the user is inputting the age in days or actually I think I'll do it in order of the problem. So months or days. All right. And if it's months, we're going to get the months. And then we'll compute years from months. And if it stays, we're going to get the days. And then compute years from days. And then both these end up going back to the same place again, where we output years. Now, I like to do something fancy after I've outputted the years. Well, then I'm going to ask the user, do we want to do this again? And if the answer is yes. Then we'll go up here. I'm going to do something fancy here. I'm going to clear the screen. And then come up and prompt the user again, months or days. If the answer is no, so this is yes. If the answer is no, then we're done. All right. So I haven't written any code yet, but what I've done is I've kind of whiteboarded what I think my solution to the problem is going to be. Ask the user if they've want to enter months or days. If they want to enter months, we're going to get the months and then compute the years from the months. If they want to enter days, we're going to get the days and compute the years from the days. Once we've got the years, we're going to output the years, and then we're going to ask the user if they want to do this again. So if they want to do it again, great, we'll clear the screen. And if they and ask them again for months or days and repeat the process. And if they don't want to do it again, we're done. Now, up until this past week, the way you would write this is you write this all in one main program, and it would look something like this. Oh, here's a great idea, or an idea. You might not think it's great, but I think it's great. If you were to sit down right now and try and write this code, which is what we would normally do in class, that would actually be really helpful for you. So you may want to take a moment and see if you can write the code to do this. I'm about to show you what the code will look like without methods and stubs. So we'll take a look at that. And there's actually a lot of code. So give it a shot. And press pause if you're going to give it a shot. All right, I'm going to assume that you've thought about this a little bit, and now we're going to take a look at a solution which does not use procedural abstraction, which is a fancy way of saying it doesn't use methods. So let's run it first so you can see what it looks like. Okay, compile. I haven't shown you the code yet. Run. All right, so enter your age in months or days. So I'm going to enter my age in days, let's say. And let's say I enter, I don't know, 20,000. And it says my age in years is 55. Well, I'm not 55 yet, but 20,000. That's cool. Let me try 16,000. 4, 5, 10. Yeah, whatever. I don't know, let's try. Well, okay, do you want to continue? Yes, I'd like to continue. Enter age in months or days. Let's enter the age in months now. And we'll enter in 1,000 months. Whoa, if you were 1,000 months old, you would be 84. Okay, fair enough. So I don't want to continue, so I'll hit 0. All right, so that program demonstrates what we want to do. Enter your age in years or days or months, and it'll compute the years, and you can continue doing that for as long as you want. So now what I'm going to do is pull this down, and we'll take a look at what the code looks like to do this. The code's actually more than a screen full of code, and it actually illustrates something that's worthwhile spending some time on. We'll look at that in just a second, but let me just take a look at the code here. So I've got a variable y or no, yes or no. I've got a variable years. I've got a little bit of code here to clear the screen with a nice comment. So it just loops for I equals 0 to 24 and prints 24 blank lines. Then we're going to get the choice, 1 for months or 2 for days. Here's the choice. And there's this weird do thing, which I haven't talked to you about, but it's worth spending a moment to talk about this do while. So it turns out that there's two types of while loops. There's a while loop and there's a do while loop. And they're exactly the same with one exception. The do while loop, the check to see whether the loop should continue or not, occurs at the bottom of the code block for the while loop instead of the top. Normally you'd see a while loop, the while up here, but the do while loop, the while occurs at the bottom. The check occurs at the bottom. And what this allows you to do is it allows you to execute the program body inside the while loop one time before you do the check, which can be kind of convenient sometimes. So in this case, we've set choice to 0, and now we have the do while executes. We do a system.out.println, enter the age in months, 1 for months or 2 for days, and we get the choice. And then at the bottom here, we check, is choice not equal to 1 and choice is not equal to 2. So we're doing a check here to make sure that the user enters a valid choice. If it's not 1 or 2, we're going to execute the do loop again, the do while loop again. So we'll go back up, execute the code block, and check again to see if we've got choice equal to 1, not equal to 1, and not equal to 2. If that's true, we're going to go back up and execute it again. So eventually, hopefully, the user will enter a 1 or a 2. All right. So next block of code here computes the age in years. So we check to see if choice is equal to 1. If it is, then what we do is we ask the user to enter months. We get the age, and we compute the age by dividing the age by 12 because we're dealing with months, 12 months to a year. If we have the age in years, in days, create an age variable again. Notice that we have an age variable here and an age variable here, and that's okay because they're sibling blocks of code, and you can have variables with the same name and sibling blocks of code. Do a system.out.println, enter days, read in the age in days, and then compute the years by taking age and dividing it by 365. So when we've computed the years, one of these two, the if or the else code block will get executed and we'll have a year's value. Then we can system.out.println the age in years, and we're going to do a ceiling by rounding up whatever value we have to the nearest integer that's greater than or equal to the current value in years. And then we're going to prompt the user, should we continue? So we'll say continue, yes or no. That'll be stored in an integer, the integer y or n. And then we have a while loop that says while y or n is equal to 1, continue. So this is another do while loop. Again, just like the previous one, we're going to do the check at the bottom of the loop of the code block instead of at the top. So if the user enters 1, we'll go back up to the top of the code here, reset years to 0, and do this for loop that prints out 24 lines of blank lines, and I'm calling that clear the screen, and we'll execute the code again. Get a choice, figure out if it's years, do one computation, or sorry, if it's months, do one computation, if it's years, do another computation. So that's how the program works. The program finally ends by clearing the screen again by printing out these 24 lines. Now, if you're like me, you're probably thinking, wow, there's a lot of code here, and it's challenging to keep all of the code parts in your brain. It's challenging to keep it in my brain. And so an alternative to this would be to do the following, to use procedural abstraction. So take a look at this. All right? just focus on the main program here. I'm actually going to I don't want you to look at any of the code up there yet. Okay. Take a look at this main program. All right. This program has the same potential functionality. Oh, you know what? I don't want to look at that either. So I'm going to do this. Okay. This main program here has the same potential functionality as the previous main program. It's just that what we've done is we've taken a lot of the code that was in the main program and we've abstracted it away into methods. So we've got a variable y or n here, and then we have a do while loop that begins by setting years to 0. And then we have a method called clear screen. So clear screen's job is to clear the screen. Then we have a method called getChoice, and the job of getChoice is to go out to the user and get their choice. Do they want to provide the years in months or the years in days? So if getChoice is 1, then we're going to compute years by saying compute years from months, invoking the method compute years from months. Otherwise, we're going to compute the years by requesting from the user the number of days and compute the years from days. And then we're going to output results and pass in the argument years. So the job of output results is going to get the results out to the user. And then we're going to check to see if the user wants us to run again by saying, wow, ask user to run again. So the job of that ask user to run again method is to prompt the user to run the program again. And if the user wants to run the program again, ask user to run again will return true. If it doesn't, then ask user to run again will return false. Now, this is exactly how I would go about writing the program from the outline that I wrote on paper. So I wouldn't write a lot of code. I just take this outline and convert it into a main program. The details of how clear screen works, how getChoice works, how compute years from months work, and how compute years from days, and how output results, and how ask user run again, the details of how all of those work, I don't need to know when I write the main program. I think of the main program as just an outline. Now, if you're like me, after you've written this short main program, you may want to just, you might want to feel like, hey, I'd like to have something running. Even if I haven't written the meat of the code, which is in all these methods, I'd like to have something running. And so there's a way to do that using a technique called stubs. So the idea behind stubs is that instead of writing the code for clear screen, getChoice, compute years from months, and all the other methods that are listed here in the main program, what you do is you put a stub in place. The stub doesn't actually do anything, any real computation, but what it does do is it allows you to get something running in your main program. And so I'll give you an example of this. Well, actually, we're going to take a look at the stub code for, well, why don't we do this? We'll write it by hand, and then we'll take a look at the stub code for all the methods here. So let's say we want to write the stub code for clear screen. Maybe I don't have any idea how clear screen is supposed to work. So what I can do is I can write a clear screen light that doesn't do much, but gives me some idea of what clear screen is supposed to do. All right, so if I were going to write a stub for clear screen, that means I don't know I'm supposed to write a for loop and do a whole bunch of system out print lines. Maybe I'm thinking it's too hard, or I'm not really sure how I'm going to do the clear screen yet. I could write a stub for clear screen. And the stub is basically like a fake method, but it'll compile and do something. So I'm going to write public static void. Now I'm writing a void here because I know that clear screen is not actually going to return anything when it's called. It's going to do something for me, but it's not going to return anything. Clear screen. Clear screen doesn't take any arguments. Open curly brace. Now, I'm not going to write the code that makes clear screen work, but I'm going to write some code in here that acts as a placeholder for code that I'll write eventually. So I'm going to say system out println clearing screen. And that's it. So this system out println clearing screen is going to let me know when my main program with stubs is running and clear screen gets invoked. I'm going to see printed out to the screen clearing screen. Now eventually I'm going to fill this, replace this clearing screen with real code. Later. So I want to say replace. Replace with real code later. But for right now, I can just put in a system out println that says clearing screen. So do you get the idea? I hope you do. This clear screen right now, when I invoke the method, it's not going to do anything. All right. Now, if I go back to look at the main program, what I'm going to do is write a stub for get choice, a stub for compute years from months, a stub for compute years from days, a stub for output results, and a stub for ask user to run again. I think what I'll do is I'll just write one more stub by hand, maybe for get choice. And then what I'll do is I'll reveal the stub code for all of these methods. So let's go over here and write the stub code for get choice. Now, if I go back to my design up here, the idea of get choice is to prompt the user for months or days. Okay, we're saying, hey, do you want to enter the data in months or days? But I'm not going to write the actual code that prompts the user and gets all that information. What I'm going to do is write a stub and defer the code that's going to have a scanner and system out print lines and getting stuff. I'm just going to defer that to later, and I'm going to write a shell of the get choice method. So public static, and I just want to go back to the code for a second to show you what we're doing here. Get choice is going to return an int. So my code over here, public static int get choice. Now, since get choice is supposed to return an int, and the goal of that int is to help determine whether if the user enters 1, we're going to do compute from months. If the user enters 2, we're going to do compute years from days. What we're going to do over here is we're simply going to just return an integer. So I'm going to just say return 1. Now, eventually, that return 1 is going to get replaced with code that prompts the user for choice. And we might say, 1 is equal to months, and 2 is equal to days, for whether they're going to enter the data in months or days. But for right now, I don't want to worry about all the details of how to make getChoice work. I just want to get my main program to run, so I'm just going to say return 1. All right. Now, I'm wondering if you can write a stub for compute years from months. Now remember, when you write this stub, what you want to do is you don't want to write a lot of code in the stub. The idea is you just want the main program to compile. The main program is going to require that the compute years from months method is written, but it's not going to require that it works properly. You can put anything you want in compute years from months. You just need to get it to compile. So what I'm going to do is ask you now to write a stub for getChoice. I'm sorry, a stub for compute years for months. So stub for compute years from months. Right? So take a shot, spend a few minutes working on that, and see what you come up with. And we'll play some lovely music while that's going on. All right, if you still don't have it working, which is possible, just chill out, hit the pause button, work it out, and then when you're done, you can see my solution for compute years from months as a stub. So compute years from months is going to return something. It's going to return the number of years. So I'm going to say public static, and I think the number of years is a double. Yeah, I can see that it's a double here. So I'm going to make sure that I do a public static double compute years from months. All right, and again, I don't want to get involved in the actual prompting of the user, say enter the number of months, getting the number of months, doing some computation with the number of months to get years. I just want to return a double, and I'm going to return 42.0. All right, that's it. That's all that you need to put in your stub. Okay, so let's take a look at the rest of the code for this program that is an example of this compute years from days or months program, but it only has stubs, right? And I'm actually going to just delete some lines here so that things get set up and we can explore this together. By the way, just so you know, actually, I think this makes a lot of sense. So what you should do, if you want to take a look at this code, is you can go to www.stonehill.edu/comp/CS103, and let's do that. Okay. www.stonehill.edu CS103, and if you scroll down to the methods in program design, chapter 6 of your textbook, this is the syllabus, and you click on program which uses procedural abstraction, stubs, you'll see the code. We're going to spend some time talking about the code inside the editor, but the code is here. And you can actually download this and bring it into Dr. Java if you want. All right? So if you go to the CompSci website, go to Methods and Program Design, and click on the link that says Program which uses procedural abstraction, you'll be able to look at the code. All right, so let's go look at the code in Dr. Java. So up at the top here, I've got a comment that says the program demonstrates procedural abstraction, and right here is my stub forget choice. In my coded example, it's saying return 0, but in the example that we did, I had it return 1. I want you to note these comments that appear above methods. This is a really good habit to get into. What you do with these comments is you create a precondition and postcondition. The precondition lists the arguments or parameters for the method and describes what their purpose is. And the postcondition describes what happens once the method has been executed. So the postcondition here says returns 1 if user wants to enter months and returns 2 if user wants to enter days. Let's actually have it return 1. All right. Here's the precondition and postcondition for compute years for months. Prompts the user for a number of months, then computes the number of years based on the number of months input, returns this computation. Let's have that return 42.0. And here's compute years from days. Same kind of deal with the postcondition, but it's prompting for days. Let's have that return 42.0. Here's output results. Notice there's a precondition here. It said the precondition is years, the number of years. So that's a comment that's indicating what that argument means or what the parameter means. And the postcondition is outputs the years rounded up to the nearest whole number. So I have a system out print line here that says stub, age in years is 42. All right? And my final stub here is clear screen that says clearing screen. Oh no, there's one more. I've got a stub that says ask user to run again. So the precondition is there's nothing there, and the postcondition is returns true if user wants to run program again. So I always have it return true. Now, all of those stubs, which basically do nothing, absolutely nothing, they do allow one thing, which is it allows me to compile the program and run it. Now, when I run it, nothing much is going to happen. But we can take a look at the execution. All right. Looks like I've got an infinite loop, so let's click reset. So that was kind of cool. I'm going to move this out of the way. Let's take a look here. Scroll all the way up to the top. Whoop. Whoa, that's a little too high. All right. So it looks like when I run the program, I see something that says clearing screen, stub, age in years is 42, clearing screen, stub, age in years is 42. Maybe what I should do is make this ask user to run again, make that false. So we just run it one time. So I'm going to click this and run it again. So what we see is clearing screen, stub, age in years is 42. Now if I trace the execution of the code, this will make a lot of sense. I do clearing screen, that's the first line of code that first method that I execute. Now I do get choice, choice is equal to 1, get choice always returns 1. If you go back to the stub, you'll see that. It's going to call compute years from months and return some number of years, which happens to be 42. Then we're going to call output results with years. And output results doesn't actually do anything with years. It just prints out stub, age in years is 42. And that's what I get here. And then it calls, the main program calls ask user to run again. And ask user to run again is set up to return false. So this while ask user run again is be while false. And so the do while loop will terminate and the program will end. Wow. Okay, this is really cool because you have a way with very little effort now using stubs of writing a main program and then writing very little code for each of the methods that the main program uses. And of course you want to write your main program using procedural abstraction because it makes it much easier to do top-down design, makes it much easier to design your program. Alright, once you've written the stubs, and if you've been very careful about writing these preconditions and postconditions, you can then begin to fill in the code that makes these stubs work. So, let's take getChoice for example. I can now take this code for getChoice and actually fill in the code to make getChoice work. Alright, so how am I going to do that? Well, I'm going to say scanner, actually, just grab the code that's up here. So it's just sitting here. Shouldn't have been there, so I'll just say this. Scanner input equals new scanner system in. Then I'm going to say system.out. Oh, let's be clever here. We'll do a do while. And what I'm going to do is prompt the user into choice and say do while as long as choice is not equal to 1 and choice is not equal to 2, then I'm going to do this while loop. It's going to loop around and around and around. And I'm going to say in here system.out.println, enter 1 for months or 2 for years. Might even make this a system out print so that the prompt is on the same line as that system out print. And then I'm going to say choice equals input.next int. Okay. Then I'm going to say return choice. Okay. Clean this up a little bit. Okay. So I've met the description of the precondition or postcondition. It's going to return 1 if the user wants to enter the year in months, and 2 if the user wants to enter the year in days. Now I can compile this and run it. And when I run it, it says clearing screen, enter 1 for months and 2 for years. So I'll enter 1 for months. Now nothing happens beyond that other than seeing that stub age in years is 42. But what I've done is I've filled out completely the first stub. And what I would do to finish the program is I would continue to go through each of the stubs, filling out the code that actually makes the stubs work. And by the time I've finished all the stubs, I'll have written the entire program. So again, this is a really nice way of doing top-down design, which is a common technique that programmers use to attack problems. Instead of trying to think of everything all at once, which is what you'd have to do if you're writing everything in your main program, what you can do is create an outline for your solution in the main program. Here's my outline. And then create stubs for each of the methods that are parts of the outline. Get your main program to compile, and then begin to tick off each one of these stubs. Write the actual codes for the stubs, fill them in. When you're done, you're going to end up with something that looks like this. This is the actual main program completely filled in. Here's getChoice. Here's compute years for months. Here's compute years from days. Here's output results. And here's clear screen. And here is ask user to run again. I mean, look how cool this ask user to run again is. I really like this particular method. it returns a Boolean, so it will return true if the user wants to run the program again or false otherwise. And it prompts the user, should we continue, yes or no, gets the integer from the user, and computes a result, saying result is equal to, is yes or no equal to 1? If yes or no is equal to 1, then result will be true. Otherwise, the result will be false and returns result. And we use that down here in the while loop, in our do while loop. So it's a really nice, clean-looking main program. We created stubs for all the methods, and then we filled in all the methods with code to complete the program. And that's a really nice way of doing top-down design. And that, my friends, is what you need to know about methods and procedural abstraction and stubs. All right.